Volcanoes are the subject of many myths and legends. They're associated with everything from gods to monsters to otherworldly portals. But what do volcanoes actually have to teach us? If you think they're just enormous holes in the ground that sometimes blow up, you'd be right. And if you think that that's boring, well, not so fast. Let's dive into it. Did you know that we have Mount Vesuvius to thank for our modern understanding of volcanoes? Sure, it also buried an entire Roman city under ash, but its eruption was such a profound historical event that it gave birth to a whole new field of science, volcanology. In 79 AD, the Romans were living their best life in Pompeii. They had no idea that a supervolcano was about to erupt nearby and turn their entire city into a parking spot for future archaeologists. In this case, parking lot is being used in the literal sense. That is, the ash fell so thickly in Pompeii that cars were abandoned in the streets and turned to glass under the weight of it. At first, the townspeople thought that this was cool. It's like a snow day, except with more choking ash and less snowmen. But then, they realized that it wasn't snow, it was pumice. Pompeii was going to be buried under tens of meters of solid rock, and they had only hours to get out before the whole place collapsed. The eruption at Mount Vesuvius was too fast to prepare for, and the people who stayed behind suffocated or burned to death, or both. Over 2,000 years later, scientists still aren't sure how fast the pumice came raining down, but estimate that it must have been moving faster than a car can drive. The disaster wiped out the cities of Pompeii, Herculaneum, and Stabiae, and raised so much dust that it blocked out the sun in some places for days. It killed thousands of people and created a massive crater where the three cities once stood. It was one of the biggest disasters in recorded human history, so it makes sense that we wanted to understand why it happened so that it wouldn't happen again. Enter the first recorded observation of a volcano, written by Pliny the Younger, a Roman senator, and, yes, related to that guy. In his letter, he describes the eruption in detail, including the fact that the initial explosion shot solid rock 20 miles into the air and created a cloud that looked like a pine tree. He also noted that small rocks were flying through the air faster than people could move their hands. This gave the first hints to scientists about the insane speed and power of volcanic eruptions, which they didn't really know much about at the time. His detailed account became the foundation of all future studies of the disaster, even though parts of it might be a little bit embellished. After Mount Vesuvius erupted again in 1631, scientists started taking the threat of volcanoes a lot more seriously. They began searching for clues about the history of the volcano by digging in the layers of sediment at the bottom of its crater. There they found ancient artifacts left behind by previous eruptions, including bits of pottery, charred seeds, and layers of hardened ash called tephra. By analyzing these objects, scientists learned that Mount Vesuvius had erupted many times in the past and would probably erupt again in the future. This led to the creation of the first volcano monitoring system ever, which was designed to warn people when the mountain was getting restless. Today, we have sophisticated instruments that measure things like seismic activity, gas emissions, and ground deformation to predict when a volcano might erupt. And while it's impossible to say exactly when an eruption will happen, we know a lot more about the risks, and we've developed plans to keep people safe. Thanks to Mount Vesuvius. And speaking of places that are hot, did you know that there's a volcano in your kitchen? It's in that countertop appliance you use every day, your microwave oven. Microwaves are a form of electromagnetic radiation. They're all around us, whether they're coming from a microwave oven, radio tower, or, the sun. When microwaves hit water molecules, they cause them to vibrate, which produces heat. That's how your microwave oven cooks food. The waves cause the water molecules in the food to heat up, which causes them to vibrate faster and cook the food. But it's also the same principle that powers volcanoes. Inside the Earth, the heat from the inner core creates convection currents in the mantle. These currents carry heat from the core to the surface, which is why the Earth's crust has giant cracks in it. Now, sometimes these cracks are in the shape of mid-ocean ridges, which are underwater mountain chains that run for thousands of kilometers. But on land, these cracks take the shape of valleys. And when they meet at a 90-degree angle, the result is a volcano. The heat from the earth warms the water below the volcano, causing it to turn into magma, molten rock that pushes upward until it erupts onto the surface. In other words, a volcano is kind of like a giant pot of boiling water. And just like when you put a lid on a pot of boiling water, the pressure builds up until it blows off. And instead of making a whistling sound, it makes an explosive one. And when it comes to volcanic explosions, some are way more explosive than others. But what's the most explosive volcanic eruption in history? Look no further than the island of La Palma in the Canary Islands, off the coast of Africa. Its Cumbre Vieja volcano erupted in 1492, just a year after Christopher Columbus set sail for the Americas. The explosion was so powerful that it literally blew the top off the volcano. It ejected 25 cubic kilometers of material, which is enough to fill 10 billion Olympic swimming pools. Ash covered the entire island and flowed into the ocean, creating new islands and completely changing the landscape of the region. And it wasn't just the size of the eruption that was impressive. The lava flows moved so quickly that they caught many of the island's residents by surprise. They fled inland, thinking that they were safe. But the lava followed them all the way, destroying everything in its path. More than half of La Palma's population was killed in the eruption, which is why it's important for scientists to monitor volcanoes closely and make sure that people are prepared in case of an emergency. But sometimes it's not the volcano that's dangerous, it's what's inside the volcano. Take, for example, Mount Pinatubo in the Philippines. In 1991, it blew its top and unleashed one of the largest volcanic eruptions of the 20th century. Millions of tons of ash and gases shot into the atmosphere, blocking out the sun and causing temperatures around the world to plummet. But the real danger came when the hot ash and gases mixed with water to form a thick mud called lahar. Lahars can travel for miles and bury entire villages. And in the case of Mount Pinatubo, they claimed more than 800 lives. If you want to learn more about what lurks beneath the surface of volcanoes, check out our series. You'll explore the deep ocean trenches where tectonic plates collide, the super volcanoes that shaped our planet, and the incredible creatures that thrive in volcanic environments. Now, let's get back to volcanoes. Did you know that the Earth isn't the only place in the solar system with volcanoes? In 2022, NASA confirmed that Saturn's moon Enceladus and Jupiter's moon Io are both volcanically active. On Enceladus, the water vapor plumes that erupt from its south pole are so tall that they punch through the moon's thin atmosphere and leave behind huge scars of ice crystals. Meanwhile, Io is covered in hundreds of active volcanoes, which scientists believe are powered by the tidal forces between Io and Jupiter. And don't forget Neptune's moon Triton, which has more than 100 known cryovolcanoes that erupt with a slushy mix of ice and water. These cryovolcanoes are taller than Mount Everest and have been dormant for billions of years. So if you're looking for signs of life beyond Earth, maybe you should start with the volcano. Alright, that's a wrap. But if you want to keep learning about volcanoes and other cool stuff, there's only one place to do it, right here. Our mission is to help you understand the science that makes our world work. And we can't do that without your help. So please support us and keep watching.